Assalamu alaikum wa rahmatullahi wa barakatuh. You're welcome to chemistry class today. We want to discuss a new topic known as water. And in this discussion, we are going to be able to understand how to state sources of water. We are going to be able to state physical and chemical properties of water. And finally, we are going to look at causes of hardness of water. Now, going to the discussion, really, water is a natural substance that can exist in the three physical states of water matter. No any other substance can exist in this form. It's only water that can exist as liquid, gas, and as solid. And water is equally known as a universal solvent because it can dissolve so many solutes more than any other liquid. We also need to know that pure water is rare to find in nature because there are some impurities that are dissolved in water, like some gases such as nitrogen gas, oxygen gas, carbon dioxide, and some salts like iron, sodium, potassium, calcium, and magnesium. All these are impurities in water. And we are going to be looking at treated water. A treated water is water that has been made to be purified through some processes of purification like coagulation, like sedimentation, like filtration and disinfection. Examples of treated water are distilled water, the ones in the laboratory, pipe-borne water. We have chlorinated water used in swimming pool. Right, we are going to examine distilled water, and we know that distilled water is a water that is chemically impure and produced through a process of distillation, and it finds its uses in the laboratory for preparing reagents and doing some analytical work. We also use distilled water in industries for production of drugs, and we have use of distilled water in car batteries. We are moving on to the next discussion, that is to look at the physical and chemical properties of water. Start with the physical properties of pure water. The following properties that we are going to be discussing can be exhibited by pure water. Now, pure water is a colorless, odorless, and tasteless liquid. It has no effect on litmus paper. That is, pure water has pH value of 7, so it's neither acidic nor alkaline. It does not affect litmus paper, and it boils at 100 degrees Celsius under standard atmospheric pressure of 760 millimeter mercury. Water freezes at 0 degrees Celsius. Water has maximum density of 1.0 grams cube at 4 degrees Celsius. Also, we need to know that water has minimum volume at this temperature, which is 4 degrees Celsius, and this is one of the unique features of water. It's only water as a liquid that behaves in this way. All right, looking at the chemical properties of water, we are going to the first part that we should be looking at is water is a universal solvent. It can dissolve so many solutes. So this example of being a universal solvent is a chemical property. So I've discussed it, but you are going to see a slide on it at the end of this. Now, looking at reaction with metals. Reaction of water with metals depends on the reactivity of a metal. Metals can be classified into 3 based on level of their reactivity. We have 1, reactive metal; 2, fairly reactive metal, 3 non-reactive metal. So starting with reactive metals. Reactive metals react with cold water vigorously to give us metallic oxide and hydrogen gas. So we have metallic hydroxide and hydrogen gas that will be liberated if highly reactive metals like sodium, potassium, calcium should react with cold water. And picking one example here, let's the calcium reacting with water, we are going to having calcium hydroxide and oxygen gas is liberated equally. Now looking at metals or water reacting with fairly reactive metals like magnesium, aluminum, zinc and iron, reacting with steam to form hydrogen gas and the metal oxide. And picking some examples here, we have magnesium reacting with water to give us magnesium oxide, and hydrogen gas is liberated as well. We could have iron 3 reacting with water to give us iron 3 oxide with the liberation of hydrogen gas. Right, then for unreactive metals like lead, copper, silver, mercury and so on, they don't react with water in any form, be it cold water, hot water or steam. They don't react at all because they are unreactive. So before we leave this, we have water reacting with metals to give us metallic hydroxide with the liberation of hydrogen, and we have fairly reactive metal reacting with water to give us metal oxide with liberation of hydrogen. Then for unreactive metals, we don't react with water in any form. Okay, looking at reaction with oxides. Here we'll be looking at two oxides, metallic oxides and non-metallic oxide. For metallic oxides, when metal reacts with metallic oxides, alkali is formed as a result. We have some examples like sodium oxide and potassium oxides. If any of these dissolved in water, we are going to be having hydroxide of a metal, which is a good example of a base. For example, we have sodium oxide reacting with water to give us sodium hydroxide. We have potassium oxide reacting with water to give us potassium hydroxide. Sodium hydroxide and potassium hydroxide are strong alkali. Right. Now, moving on to the reaction of oxide of non-metals with water. The result here is an acid. If oxide of non-metal should react with water or should be dissolved in water, acid is formed in the end. For example, we have sulfur oxide reacting with water to give us sulfuric acid. So we have SO2 solid plus water to give me H2SO3, which is sulfuric acid. And all these chemical properties we have talked about lie under water being a universal solvent, being able to dissolve so many substances, so many solutes, more than any other liquid. All right, we are going to be looking at types of water. Water can be classified into two types. We have hard water and soft water. What makes water to be hard is the presence of dissolved salts like magnesium salt and calcium salt. What is hard water? A hard water is a water that will not form lather readily with water. And some examples of hard water, just one example of what I'm going to mention here is mineral springs, water from mineral springs. Okay, you can equally have water from where to we add water because it contains some dissolved salt. Then for salt water, we have salt water to be water with low or no dissolved mineral salt in it, and examples include all treated water like pipe water, chlorinated water, distilled water. And the hardness, the little dissolved salts in these type of water can be removed through process of distillation or by boiling. So we know that water, soft water, does form lather very well with soap, while hard water does not form lather at all with soap, or it doesn't form lather so easily with soap. And for hard water to form lather with soap, it means more of the soap must be used. Large amount of soap must be used for it to, for soap to form, for hard water to form lather with soap. So another thing to be noted is that using of detergent has helped to overcome the problems of hard water in laundry, because detergents are unaffected by hard water, by the dissolved salt in the hard water, because they form detergents form calcium and magnesium salts which are soluble in water. Then what is the cause, or what are the causes of hard water? Hard water is made to be hard as a result of the soft gypsum or limestones from the soil from which it flows. And we have the equation to portray that: calcium carbonate plus calcium oxide with water to give us calcium hydrogen triazocarbonate 5. Then we are going to be looking at types of hardness of water. I just want to use this slide to introduce to you types of hardness of water. This is going to be discussed in our next class by God's grace. We have two types of hardness of water. We have a temporary hardness of water and a permanent hardness of water. So in my next class, I'm going to be looking at what made temporary hardness and what made permanent hardness, and how can we remove hardness of water. In the next class, we are going to be looking at what are the effects of these two types of hardness, and what are the advantages of temporary hardness over permanent hardness, and vice versa. Thank you for your time. Please do subscribe to my YouTube channel for more videos. Bye.